Let's look at this DC1 at night. Let's look at it without the lights on first. No overhead light. It's so nice at night. It's so freaking good at night. Let's look at this vision, because we're going to talk about why the autistic phenotype gets flooded with vision. We're going to make sense of eye gaze. It's not that complicated. Eye gaze is not that complicated. We're going to map this out. We're going to do a video about corollary discharge. The retina has two projections coming in from the retina. One to the superior colliculus, about 15% of the projections. The rest of it goes to the lateral geniculate, 85 to 90%. It's on the thalamus. We talk about this stuff all the time. This pathway right here comes fast. You don't even know what's happening. Retina, superior colliculus. Remember, this machine-like barn owls are great. Optic tectum. 15% of the fibers go here. This is like a freaking massive relay station. Then it'll speak up to the thalamus. Mediodorsal area right here. There's a better picture of it. Bless it. Right here. It's right here. This is the thalamus. Reticular nucleus shell right here. Medial geniculate for the auditory. Lateral geniculate, which gets about 85% of the retina's fibers. Visual relay station right here. But this superior colliculus, right next to it, they reach out and high-five each other. That's in the mesencephalon. The superior colliculus will reach up to the thalamus, mediodorsal, and then the mediodorsal will send this long-distance connection to the frontal eye fields. That's a long-distance connection here. This is a problem for the autistic phenotype. Then the frontal eye field will speak back down to the mediodorsal. It's a little feedback loop there. It's constantly keeping it updated. This projection right here sends the corollary discharge. It's a prediction of the map. It's a motor map. This is what motor movement I'm going to perform. And this is the expected outcome if I do that, if and when I do that. You don't even know you're doing this. This is a prediction machine. It prepares us, all of us. But the autistic phenotypes is delayed. Then the frontal eye field will speak over to the parietal lobe, helping it make sense. And it'll kind of break off into two different regions here. Then it'll speak back down to the thalamus. Parietal to the thalamic reticular nucleus here, that protection shell. And then to the lateral geniculate. But the TRN, remember, we've done great videos of this. This is a protection shell. This is mostly full of parvalbumin. And then there's some somatostatin inhibition too, but mostly parvalbumin. The autistic phenotype has very bad problems with this. So the TRN will let more information come in to the lateral geniculate in the autistic phenotype versus normals. And then this is where the saccade happens. This is the eye movement. All of this stuff right here happens even before the eye movement happens. We're talking about minus 60 milliseconds. That happens to the time the eye movement actually happens. All of this is happening. It's so fast. It's a machine-like. And then what gets sent to the lateral geniculate will then hit the visual cortex. This projection mostly bypasses V1 because V1, there's no need. This isn't really so much sensory processing for raw visual information. That's this pathway. This is just prediction and preparation. Also, the frontal eye fields over here will speak up to the dorsal lateral prefrontal cortex for some working memory and some so-called executive functioning. What the hell is that? What the hell do they even mean whenever they say executive functioning? Give me a break, people. Define it. Define it. And then also this area right here, the orbital frontal cortex, will receive a lot of information. Not raw sensory information, though, But as soon as it hits the parietal and from these brainstem areas, it receives process sensation. And this will be heavily involved with latency and state-dependent actions. What does this value mean to me right now? It's not necessarily attaching value to it, but it's very state-dependent. How do I feel right now, and what is the information coming in? What is the information that the living organism is receiving? So what does it mean to me now? Not last time, not in the future, now. So this is very fast acting. And then it will also feed forward and stuff with the actions, because by now we've hit the visual cortex and we're processing this stuff. By now we've hit the saccade. So 85 to 90% of the projections are actually doing this. Retina to that lateral geniculate to V1. This is a big pathway to V1. Remember, this pathway bypasses V1. This one doesn't. This is most of the visual information. This pathway right here is all prediction, preparing the living organism for that action. This corollary discharge, we do this with all sensations. Auditory, touch, it's all happening. But it's very complicated here with autism because of this TRN, and by the time it feeds back down, this TRN floods. It floods the lateral geniculate nucleus. So it's just flooding the visual cortex. Attention to detail is happening here. Time on task. Accelerated learning is happening here. It's not that complicated. The autistic phenotype is not that complicated. Now, you might think it's complicated because the centralized government, the controllers, want you to think so. They love that though. They want it to be confusing so they can just continue to get away with stuff. Anyways, this was about the DC1. So look at it with the lights off. And look at it with the lights on. With the lights on, you don't even need backlight. See? Backlight all off. Backlight is all off. It's just working off of this light right here. It's so freaking cool. But you can use the discount, but I should probably let you know that, like a paid partnership or whatever, I don't know. It's the definitions. But we're going to parse that out. It's going to be so freaking fun because you don't even know you're doing this. Remember, this is happening before the movement even begins.